this computer. And I'm going to go ahead and pop open something I put on Slack last night. Just a couple of questions from the exam that people seem to, actually, don't I have it in a, that was our second one, right? I'll just paste it, the other thing in here. So on the, all the midterm grades are up, they've been turned in. So if you're having problems in one of your classes, they should have yelled at you by now. So if you, that hasn't happened, you're probably okay. On our exam, you know, most of the exam people did fine. And even a lot of the programming questions, folks did pretty reasonably on. There were a lot of A's on the exam. You know, most of the grades were 70s or higher, which is, I think, pretty solid. So, you know, if you were in that range of, you know, 70% or better, that means I would say you have a pretty decent understanding of kind of what's, oh, is this guy didn't come on? Ninja. Look at that. See, that's why my knee doesn't hurt. It's magical powers. Oh, oh, Ninja. Okay. It might flicker some because it seems like it's on the fritz. But in any case, if you got a 70 or better, I would say you're probably in pretty good shape. You know, you may have made some mistakes. I tend to grade the stuff fairly easily. You show me some competence. I would maybe look at what points you missed. If you missed stuff on programming questions, maybe you got, you know, 3 points off here, 5 points off there, stuff like that. There were a couple of obvious situations where people missed points where they kind of misread the question, that kind of thing, and they answered something different. Kind of not a lot I can do about that, but I try to give you a comment indicating that what you actually solved was this, which is somewhat similar. Sometimes it was obvious that somebody had memorized something else and they just inserted that as their, as their answer, regardless of what question I was asking. You know, it's like a political debate, right? Doesn't matter what you ask them, they're just going to give you something prepped. But in general, the programming stuff was pretty good. So look at your exam. If a majority of the points you missed were on, you know, mistakes with the conversions or, you know, short answer stuff, then, you know, go back and review those types of things. But if it was in the programming stuff, that's the practice stuff, right? That's the stuff you need to keep putting the reps in. So my position would be this: if you got a 70% or better on the exam, you probably did reasonable on the programming questions. If instead your 70% came in the form of acing everything else and getting basically zeros in the programming questions, you're not where you should be. Okay, but if you had a good mix of losing points kind of throughout and just need to tighten up some of the knowledge, that's okay. If you did very poorly on the exam, you know, there was, I think the low grade was 14%, something like that. You know, then you got to really consider what effort you've been putting into the class up to this point. And, you know, hopefully these things are wake-up calls, because, you know, the idea is that I do have the policy where if you do better on the final exam than you did on the midterm, I'll replace your midterm exam grade with whatever you got on the final. So you do have a way of still fixing it, but, you know, at least have a little discussion with yourself as to why you did so poorly, you know, whatever it is. But anyways, I wanted to give you the solutions to the programming assignments in there. So on number 4, you were supposed to print out all of the odd numbers between 1 and 100,000. So I gave you a couple of options here. What's always funny to me is some of the people would like just do like 1 to 100 or something. Like they did the right thing, but just didn't count high enough. I didn't take points off for it, but like why?
Put some water in it, put it in the microwave, heat it up, pour the water out, so the inside's still warm for you to
got unmuted. I had that happen in another class a couple of weeks ago, that it was far less PC than that. It was and one of the other professors, I think I mentioned in here, had some roommate walk behind somebody not wearing clothes. So in any case, a couple different solutions to this. So this is just our stock for loop that goes through every value between 1 and 100,000 inclusive. That's why I go to 100,001. All right. Now, could you have interpreted when I said between 1 and 100,000 that I actually wanted you to go to 99,999? That's fine, you know. But my intention was to make sure you knew that this was non-inclusive. Now you can step by 2. So that means you go from 1 to 3 to 5 to 7. So you're just hitting the odd numbers, printing every one of them out. Or you can do kind of your stock for loop where you go from 1 to 100,000. Each time through, you ask the question, is it odd? So if I mod 2 is equal to 1, if when I divide I by 2, it has a remainder of 1, that means it's an odd number. Therefore, I will print it out. All right, so 2 possible solutions to that particular one. These are up on the Slack if you want to take a closer look at them. Next one was count spaces. So you're supposed to write a function that goes through a string and just counts the number of spaces it finds in that string. So any way you cut it, you're going to have a variable. You're going to remember the number of spaces you found up to this point. So this is kind of going back to the idea of how do human beings solve problems? Memory, asking questions, repetition. So we're going to remember something, remember the current count. This is going to go through every character in our string, where C will be equal to the current character. If the character I'm looking at is a space, if it's equivalent to a space, add 1 to my count. Do that for every single character in the string, ultimately return the value of count. Alternatively, if you don't like a for each loop like this, where C is equal to each individual character of the string each time through, if you'd rather have it be a counter and then extract the character from the string, you can have a normal for loop. So I is in range 0 to the length of the string. Then ask the question, is the character I'm currently looking at, which is equivalent to C up here, but is the character I'm currently looking at, the character that lives at bucket I in my string, is that equal to a space? If it is, increment count. Ultimately return count. Make sense? All right. Another one, reverse string. Taking a string, we're going to build up. So this was testing that you understood concatenation. So we're going to build up a new string. So we're going to start off with remembering our answer, starting off as it being the empty string that we're going to build onto. All right. I know that in Python, and I gave you some comments if you did this, there are some shorthand tricks for like reversing a string and stuff like that are built into Python. And that's fine. If you know those things, you can use them. But I encourage you to make sure that you understood a loop version of this. Make sure you can actually go through the logic, because this isn't about knowing how to reverse a string. This is about being able to go through a string backwards or forwards or whatever and do something with each individual character. Make sense? Okay, so just because Python, we had a discussion in one of our classes about this, just because Python has these built-in magic tricks that let you do some, if you remember, it was the time when I was kind of complaining about Python has in some ways too many different ways of accomplishing stuff, has a lot of conveniences built into it, which is great when you're a advanced programmer, you're working full-time, writing Python code in a job somewhere, and you don't want to have to write 6 lines of code when you can just quickly write 1 line that does something. That's great when it's just go-to move. But right now we're trying to get those reps in of practicing programming skills, regardless of what we're actually doing. So the fewer shortcuts you can take, the fewer built-in things, the better for you right now. So whenever somebody used a shortcut, I gave you the points because it's entirely possible that you've had this stuff before and you just know this is the answer and it was the most efficient way of giving it. That's fine, but I challenged you to at least make sure you knew how to do it the other way. Okay, so I'm not using any shortcuts here. I'm going to remember a variable. I'm going to start it off with the empty string that I'll build onto. So this was testing that you understood that when you want to build up a string, you can use the empty string as a base for building up a new string. Okay. And then this is that same for each loop where I'm going to see C is every single character in a string. So the first time it would be bucket 0, then bucket 1, then bucket 2, but it would be the actual character that lives there. All right. And then what I would do here is I would build up answer string in reverse. Notice I'm tacking on my character onto the front of answer string. So this will build it backwards. Okay, as opposed to, if I just show you an alternative thing here. So let's call this reverse string, a string like this. I can say answer string is equal to the empty string. And then maybe I can choose to go backwards through my string. So I write the other loop. Instead of building it backwards, I walk it backwards and build it forwards. So I can say something like for I in range of the length of a string -1, because that's the last legal bucket of a string, right? If a string has a length of 5, the legal buckets are 0 to 4. So -1 all the way up to, but not all the way down to, but not including -1, stepping by -1. Okay, and then I can say answer string is equal to answer string concatenated with a string at bucket I. Ultimately return answer string. So this loop will take I on a voyage between the indexes, the legal indexes of a string, starting with the last legal index and walking towards the first legal index, which is bucket 0. Make sense? Each time through, I'm building it onto my answer string, but notice how up here, I'm taking the character and putting it onto the front of answer string. And here I'm taking answer string and I'm putting the character onto the end of it because I'm walking the string in reverse. Instead of walking it forwards and building it in reverse, I'm walking it in reverse and building it forwards. Make sense? All right, so these are both, viable solutions. I think both of these have some good skills. So I don't know that one of these solutions is better or worse than the other one. This one kind of is good practice for kind of walking a collection backwards. This one is good practice of kind of understanding that concatenation doesn't always have to tack something onto the end. You could also tack things onto the front, something like that. All right, so these should be all things that are in your wheelhouse. All right, so questions about any of those before we go over what was in the lab from last class, and then we'll start getting into some other things. All those programming, go ahead.
I can't recall right now for some reason. It's like with your second example of reverse string.
Yep.
For I in range, I don't remember if I did this or not, but I think that I maybe put 0 equal length of a string. Does that mess it up? If I put a 0 after between range and length, and then it's equal.
You put
range 0 to the length of the string. You know what I mean?
Okay.
That won't mess it up, will it?
So if I go 0 to length of string, just like that?
No, but with the -1 and all of that stuff. Walking it still in reverse.
I don't know the answer to that. I think that won't go through.
I can't recall if
that's not going to go through. I mean, here, we're asking the question. Let's test it real quick, right? So here, I'll just come down to my main. I'll just get rid of these things for a second. So we'll go ahead and do for I in range, and you went from 0 to, here, I'll just do the length of hello, something like that. But you want to step by -1 like that, and I'll go ahead and print out.
So still walk the whole thing in reverse from the last legal bucket, blah, blah, blah. Or does that first?
Well, but this is what you wrote up here, right?
No.
What did you write up here?
That's what I was trying. I don't remember if I put 0 there or not, if I just had range length of the string. But I'm wondering if with that 0 there, would that mess it up?
Well, yeah, I mean, this is the starting value.
Okay.
This says start I off at here and go to this value, not including that value, stepping by -1. So what would the output of this be? If I start at 0, go all the way up to, but not including, in this case, 5, but I count by -1, what should the output of this guy be? Correct. So hold on. This is, I have the rules somewhere. Well, the output is nothing because I never got into this loop.
Right, yeah, it just went backwards.
I failed it right from the get-go.
That's not what I meant, but it's cool to see.
Yeah. Yeah, so you,
I left that 0 out. I was just trying to recall right now if I did that, but I obviously didn't.
yeah, I mean, I would have to know exactly what you were trying to write to see, but I mean, the syntax for range is beginning of range, end of range, not including that. How should you move? The default is move forward by 1. We've updated to move backwards by 1. So if I change this to move forward by 1, now I get output.
So, but if I erase the 0, right, and I do range length of string, then
Step by -1.
no, with the other, like, starting at the last legal bucket down to 0 by -1.
So you have an extra thing in there?
No.
Tell me exactly what to type.
Okay, right where your cursor is. This is what we normally do. -1, last legal bucket, down to 0.
Well,
and then
what's
stepping
so?
back by 1.
What do you mean by last legal bucket?
Right after hello. Right after the parentheses.
So you want to say this?
Last, like
That's the last legal bucket.
Yeah.
Okay.
Going down to 0, so -1 again. No, -1 again.
Okay.
Like you normally have it.
Yep.
Right? What are those being applied to? To the range?
It's being applied to I.
Oh, okay.
So when we print this out, this will print out a 4, then a 3, then a 2, then a 1, then a 0.
Okay.
So this guy produces a collection.
Yeah.
Starting off with this number, which in this case is a 4, going all the way down to this number, but not including that number, which would be a 0, stepping by -1. So this would be a 4, then a 3, then a 2, then a 1, then a 0. And there's our 4, 3, 2, 1, 0. So that's what range does. This guy produces, that. In fact, if we do that, if we say we could be, that's a tuple, we can also do it as a, so if I say 4, 3, 2, 1, 0, like this as a list, and then comment out the rest of that, this will give me the exact same output. Oh, no, it doesn't. Oh, not yet. So there's my 4, 3, 2, 1, 0. Similarly, this will work too. This is what's called a tuple, even though we haven't made that a major part of the class. This is like a read-only list. It's in the notes, but it's a list that you can't change. So I think the notes refer to it as mutable versus immutable. Mutable being changeable, immutable meaning not changeable, just fancy words to make people sound smarter, something like that. Okay. All right. So any other questions about kind of those coding drills? These are good drills to work on. And then once you kind of have these under your belt, and you want to challenge yourself. So, Ben has put up on Slack, if you've noticed, a link to something called codewars.com. We're actually going to do a problem from codewars.com in here today. I found it to be an interesting problem, and you can kind of see how it extends you. Now, some of the problems you might run into on there are going to be out of your range, right? They're going to be too complex for you, but you kind of want to keep practicing. Almost think of it like you're trying to get good at basketball or baseball or soccer or whatever. Pick your sport. And, you show up to practice, right? And your coach has you run through drills. These are our drills we're running through, right? And let's say you get to the point where you feel like, I'm kind of ahead of the rest of the team. The drills are kind of boring. Those are skills I already have. But while everybody else is catching up, getting better at those drills, you kind of want to keep your advantage, right? So you got to go and find other ways to challenge yourself. Now, I just started looking at Code Wars this morning, actually. I was in the pool looking at it on my phone. And actually found it fascinating. When he originally had posted the link, I had thought it was something similar to, I don't know, it's not this, but there was a thing a bunch of years ago called topcoder.com, which was a computer programming competition where every week they would have 2 or 3 different programming competitions things, and they were timed, and you had like a easy, medium, and hard problem. And maybe sometimes a 200 or 250 student could kind of handle the easier problem, maybe occasionally the medium problem, but you know, it was all time, there's pressure. It wasn't really practice. They did have a practice thing that had old problems from it, but it was more of a competition-y type thing, kind of like taking your, you know, pick your favorite video game, playing, you know, online leagues, online matchups, something like that. Still interesting, but this one was really kind of an educational tool, and I was pretty impressed by it. So I'll hopefully introduce you to it a little bit today with this problem. I actually already put it in the slide set. We'll look at it in a few minutes, but it's something I think worth looking at, to find those problems that are just kind of right at you, the tips of your fingers. You know, like, I get what they're asking me to do. I think I can kind of make a stab at this, but I can't just sit down and write it. I'm going to have to critically think through this. I had to draw some pictures, stuff like that, because you want to create those challenges for yourself to keep practicing when you feel like the course content isn't challenging you, because the course content's trying to challenge the larger group of students who are at various levels of learning the stuff right now. Go ahead.
I was just to add to that, I've had questions that were, well, maybe not as simple, but like reversing a string all
Sure.
the way up to some that were super complex that I couldn't even probably explain. But if you can't figure it out, you can actually click to view the solution,
Sure.
like unlock the solution or whatever, and so you can kind of get a chance to like see, you know, how these other people are writing code, and like, for me, that's a nice way for me to learn. I like to see.
Yep. Now, if you choose Python as your language, again, make sure you're careful about when you look at other people's solutions. Sometimes they'll use some of those power tools that I think maybe hide the real solution from you. They kind of do stuff, but you know, one of the struggles, I was going to say that we're all students at some level, right? One of the struggles we sometimes have is coming up with, you know, like, oh, I want to solve a problem that does X, Y, and Z. Well, sometimes it's hard for you to come up with your own little problem to solve. I kind of tell students, well, find a little utility that you want to, you know, have exist. The story I tell about how I got into iPhone development is I had just come to Concordia in 2006 when the App Store was had just been announced, and I hadn't unpacked all the stuff in my house. And some of my students wanted to play Dungeons and Dragons, the dice roll, you know, tabletop stuff. So I decided, well, my first iPhone app will be a dice roller. So I wrote a dice roller with it. I needed a solution to something that was going to benefit me in real life, seemed to be, you know, kind of in the wheelhouse of, you know, I just wanted to learn the technology, learn the stuff that's in there. And I wrote it. I turned around and then sold that and made stupid money off something stupid just because of timing. That's just how business works, I guess. But the punchline is that whole thing was to write a utility that allowed me to solve a real life problem because I was too lazy to unpack the boxes and find my actual dice. True story. the whole thing. In any case, sometimes it's hard for us to come up with those challenging questions for us, right? So far, just for 20 minutes looking at Code Wars, I was pretty impressed with the stuff that you can do in there. And those are going to be the types of things that you maybe want to force yourself to do over, you know, Christmas break, for example. You know, when you're, you know, out of practice programming, you know, Littman's no longer forcing you to do these assignments, and now you're kind of just buying your time and forgetting stuff before you get forced to do assignments again in 250. You know, this will kind of keep you up, and maybe you can treat it like this is the video game I'd like to play, something like that. All right. So let's look at the lab from last class, and then we'll look at that problem from Code Wars. So the second half, or the last 6 weeks of the semester here, we're going to be focusing on object-oriented programming. Okay, and this lab was to kind of put that back into our forefront. And the reason we had the lab and I was able to be live on Slack, but not necessarily in class, is I was waiting in a surgeon's office for results of an MRI and stuff. But there wasn't a reason why I couldn't reply to stuff. I just couldn't be sitting in front of a laptop on Zoom. So I figured I didn't want to cancel class, so this was going to give us a push in the right direction. So in any case, we want to think about, again, the idea of object-oriented programming is our programming languages themselves are meant to allow us to solve problems in a way that's similar to how we solve problems already, right? And we think about the world in terms of objects, okay? So I gave you an example dealing with golf clubs, but I gave you all the information you needed for them. It has a name and it has a distance, whatever that means, a name and a distance, okay? And so if I were to hand any of you a golf club, even if you're not a golfer, you could pick it up and say, yeah, this looks like a golf club, right? You kind of, most of us could recognize one if we saw one in the wild, that type of thing, right? We might not know how to hold it, might not know how to do it, what to do with it, but that's a golf club. We think about things in terms of objects. This object is a golf club. Now, I gave you the information that every golf club has a name and it has a corresponding distance. All right. So when I'm playing golf, so most of you kind of gather this is I'm an avid golfer. I play tournaments and stuff. So, and the distances I gave you are actually the distances that I hit my clubs. So these are Lippmann's distances. If you watch professional golf on TV, you notice that 230 is not going to compete very well. I'm a little bit shorter than the pros are hitting it. But in any case, the idea is when I'm on the course and I have a 100-yard shot, I need to pick the club from my bag that is going to hit it that distance, right? And there's, some problem solving related, because if it's uphill or there's wind coming into me, or maybe the flag is 100 yards away, but it's all the way at the back of the green. And if I hit it over the green, it's bad news. Maybe I'll pick the 90-yard shot and try to get it as far up as I can without being in trouble, something like that. So there's more problem solving than just this. But if we keep it simple and say, I need to hit this ball 100 yards, I'm going to look down in my bag and I'm going to say, which of my clubs hits the ball 100 yards? And I'm going to see that's my pitching wedge. Okay. These are things I've already remembered in my head, but if I'm writing a computer program that's going to allow me to do that, I have a golf bag. I have a collection of golf clubs. Each of those clubs has a name and has a corresponding distance that I hit it. Make sense? So because we think about things in the real world in terms of objects, we created a framework here for developing golf clubs. We said that we have this object named a golf club, and this object keeps track of two pieces of information. Every club has a name and it has a distance that it goes. And those are the pieces of information we need when we build a golf club, okay? So if I have a bag of 13 golf clubs, the putter gets built with a name of putter and a distance. I just picked 20. I've actually tried to hit putters farther than that. Sometimes when you're behind a bunch of trees and you got to hit it real low, well, nothing goes lower than a putter. So you just take a full-on crack at it and hope for the best. But the punchline is I just made up a putter can go 20 yards when the spirit is willing type situation. Usually you're hitting 12-foot putts or something with it. But, in any case, I have a putter that has a distance. I have a sand wedge that has a distance. I have a gap wedge that has a distance, a pitching wedge, a 9-iron, an 8-iron, so on and so forth. These are all individual objects that are all the same kind of object, but have different properties. Does that make sense? That's what objects are all about. So you can think of this guy as being kind of like a blueprint. This is our design for how to make a golf club. Just like if you're building a house, somebody's going to have a blueprint of how to build that house. But then you need to go and find somebody who actually builds it, who can construct that house for you. And who does that for us? This guy right here, the constructor. I give this constructor a name and a distance, and he will build for me a golf club. That makes sense? All right, so we build a framework, a blueprint for how to make golf clubs, and then we use that framework to actually make a golf club. So what I have highlighted right there is creating an instance of the golf club class, passing it one of my club names and passing it one of my club distances. So notice here I created two collections. I created a collection of all the names of my clubs up here. And then I also created a collection of the exact same length with the distances they go. So bucket 0 here goes the distance of bucket 0 here. Bucket 1 goes the distance of bucket 1. Bucket 2 goes the distance of bucket 2, so on and so forth. Okay, so we would call this approach parallel arrays, okay, or parallel lists. I have two lists that have the same number of elements in them, where the element in the first list at bucket 5 it corresponds to the value that's at bucket 5 in the second list. So I'm using those two pieces of information to, and this isn't how you had to do it. Some of you created dictionaries or something like that, and that's fine. Some of you just hard coded it. Some of you just said, create a golf club named Putter, that was 20. Create another golf club named Sandwich, that was 70, so on and so forth. This was just I wrote some strings. Here's our two lists right here. I had my list of clubs I was going to fill up. I could have called this golf bag, right? So this is my golf bag that has a bunch of clubs in it. I went through every element, and I could have picked list of club names or list of distances here because both of these guys have the same length. Go ahead.
So I saw what you did and I copied it and did it myself, but then I tried to access a specific instance within list of clubs, and it spit back out the function number address or whatever, the object address. So if I try and access list of clubs at bucket 0 or something like that, that was actually never created.
Okay, so you want to say print list of clubs?
Yeah, bucket 1 or 0, yeah.
Okay.
And I think it's going to print out to you the object.
It'll print out a memory address.
Yeah, that's what it did.
Yeah, because that's where that object lives.
Oh, so why didn't it print out because you technically constructed the list, or is the list not really actually constructed?
It is constructed. If I print out list of clubs, this guy, it'll print out a list of addresses.
Oh, so
this is where in memory each of those clubs was created. When you build a house, let's say you have this blueprint for a house, just like we have a blueprint for a golf club here, right? We have a blueprint for a house. Have you ever been in one of those neighborhoods where all the houses look the same? Subdivisions, right? Okay, every single house looks the same, or you have 2 or 3 houses, something like that, 2 or 3 different designs, but let's just say there's one design. So they took that same blueprint and they made a house at address 0, a house at address 1, a house at address 2. The addresses are more complex than that. So a house at some random hexadecimal number, a house at another random hexadecimal number, a house at another random hexadecimal number. So these are physically different objects, physically different houses built from the same blueprint, right? And they have different locations on the street, different locations in the computer memory. So when you print it out, list of clubs at bucket 0, what lives at bucket 0 inside of list of clubs? A golf club. In this case, it happens to be the golf club that was built with a name of Putter and a distance of 20. But just because it has those two pieces of information, you didn't ask for those two pieces of information. If I would have said .name, it would have said Putter.
Really?
If you would have said .distance, it would have said 20. But that's not what you said. You said, give me that value. What is that value? It is a golf club. But these guys are, remember we talked about pass by value versus pass by reference? And I probably brought up some example of, let's say you have a party or something like that, and you're inviting me over. And do you give me the address where you live, or do you hand me the house and tell me to open the door at 8? In real life, it would never make sense to give you the house, right? Okay. Similarly, I guess in real life, we might say that golf clubs are light enough where you could probably hand somebody a golf club. Okay. Modern programming languages basically treat anything that's an object, it treats as being really heavy. Okay. Or at least potentially really heavy. Because objects might hold a whole bunch of pieces of information. They might have a whole bunch of functions, blah, blah, blah. All right. So basically anything that's an object is considered too heavy to hand somebody physically. So instead, when you need to hand somebody an object, you have to tell them where they can find it. You can kind of think of it like all objects are like houses. Okay. If somebody says, come to my party, you don't give them the house, you give them the address of where that house is. So if I say, show me the object that lives at bucket 0, it's going to show you the address where you can go and view it. that make sense?
Is
Go ahead.
there a way to view, like to manually, like say, show me input that address in code, and it'll then show you putter 20?
Not in, so what he's saying is can I take, if I have the address, so if I have the value of this guy, so this guy gives me crazy address, right? If I have that address, can I say, give me the thing at that address? In Python, no. In some older languages like C and C++, you can. And this is actually,
I would never do that, but I just.
well, and this is the thing. So this is one of those reasons why some of these languages have evolved, or been updated, and that's because what you just said, having direct access to manipulate memory, is a powerful thing, and maybe every now and then it would be helpful to do that, especially so. Bottom line is, if you've heard of people who write viruses, malware, stuff like that, chances are they're working with a language like C, a language that allows them to directly manipulate memory, directly go to a place in memory that might not be owned by this program, that kind of stuff. So, kind of with great power comes great responsibility type thing. Now, sometimes for a seasoned programmer, they might be working on a problem that they legitimately might have a need for that. So with some of these newer languages, they might be somewhat handcuffed from solving a problem the way they really want to solve it, because the modern languages lack those tools, because very, very, very rarely do you actually need it. And I'm going to just say almost always, because I can't come up with an example that breaks it, but almost always there's another way of accomplishing what you want to accomplish. Okay. But this kind of falls into that category of how many of you have heard of BitTorrent before? So most of us have heard of torrents. Now, when I say, or at least some of you have heard of torrents, when I say torrent, the first thing that probably comes to your mind is stealing music, stealing movies, things like that, right? We think of that technology as being synonymous with getting digital things illegally. But the reality is that there's nothing natively illegal about BitTorrent. In fact, most of our modern day software that, operating systems, video games that do updates use BitTorrent as the mechanism for doing updates. Because what BitTorrent does is it allows you to, if I'm getting a file and all of you already have that file on your hard drive, I can get a little bit from you, and a little bit from you, and a little bit from you, and a little bit from you. And what that does is my download is each of your uploads on your internet connection. And it might be that I have a 200 megabit per second internet connection. Your upload is 20 megabits per second. So the fastest I could theoretically download from you is 1/10 the speed of what I'm capable of. But if I get 9 other people who all share part of that file with me, now I can maximize my connection. Kind of see how this is working? So BitTorrent itself is a good technology, and it's used for a lot of good things. But for those of you who have, I'm sure, legally used BitTorrent for all sorts of very good, positive Christian things, when I said BitTorrent, the first thing that probably came to mind was, oh, that's where I download my movies, right? Okay, so that's a situation where you have a technology that could be misused, but the problem isn't necessarily the technology. When we talk about something like C or C++ that gives you the power, the technology to directly manipulate memory, in the right hands, that could be a powerful tool, but I would argue that is only useful every now and then. But in the wrong hands, or from an educator perspective, in the inexperienced hands, it's something that can take you down a dark path that is difficult to debug. So you either purposely meant to access a part of memory that's, bucket 60 in a list when that list only has 4 things in it. You either purposely meant to do that, or you're a beginning programmer and you're just guessing, right? Either way, it's bad news bears. Okay, so a lot of these newer languages, they are designed specifically to take some of those decisions away from the programmer, because they're often not needed. But also, I view it as it also protects the beginning programmer from themselves, something like that. Make a little sense? Okay, so that was your answer to the question of if you had a memory address, can you just go there? In C and C++, yes. If you have a memory address, you can just go to that memory address and whatever it is, you have it.
I didn't really realize the depth of my question.
Yeah.
That was pretty intense.
Yeah. Well, but and that's the thing. That's the point of tech, and that's why we're here as computer scientists, or computer scientists in training. We don't realize how deep the rabbit hole goes, right? Because we grew up in a society where we've all been using iPads or something like that since we were kids, right? Technology has been around us since we were kids. Not for me, but more so for me than Dr. Locklear, for example. I mean, he's significantly older than I am. So when he was a kid, I mean, I think they had electricity, but I think they were still doing the stone tablet. But so I remember the the wired telephones with the finger dial thing, and dial tones, and we didn't have the internet. We had a phone book, a physical phone book. So those are things, and that was the good old days where when he was a kid, there was a time when there wasn't TV. They had radio, so you get to keep going back. And so, you grew up during a time period where technology is always available to you, which is great from a convenience perspective, but also bad from learning to be a computer scientist perspective, because so much of these details were hidden from you, even though you're intellectually capable of understanding them. You just never saw them, right? The first time you saw a memory address is probably in here, right? In this class. That's the first one time you were exposed to it, even though you kind of know that, oh, stuff is stored in memory. One time I knew a guy who asked me, if you just download more memory, you wanted to upgrade your memory, do you just download it? That was Ben, everybody online, by the way.
I feel like we should be able to do that at this point.
But you see the point. It's not that you didn't understand that memory was important. It's that it's this mysterious thing because we haven't been exposed to it, right? I grew up during a period of time where we were directly working with memory, but not quite at the level where I was using a soldering iron to directly manipulate memory. Then you go back to the earlier days where you have vacuum tubes. You probably look at some of this stuff in the 175 class, maybe, where you had these computers that were the size of gymnasiums, and you wanted to turn one bit on, a 0 or a 1, you turned a little light bulb thing. Physically manipulated that bit. Different day and age, right? So yeah, memory address is super important, but in most of our modern languages, having the memory address directly will not let you do much. Now, having said that, let me just show you an example though. What is this Boolean expression testing?
Memory address of 120 is equal to list of, or memory address for whatever the second one.
Yep. This is not saying, is this golf club equal to this golf club? What it's saying is, are both of those stored in the same location? Because this boils down to a memory address, a pointer that points to where that golf club lives in memory. This boils down to a memory address, a pointer, which points to where another golf club lives in memory. We're asking the question here is, are these two memory addresses the same memory address? Are they both 1, 2, 3, 4 FF? Make sense? Not do the two golf clubs have the same contents? Are they both putters that go the distance of 20? That's not what we're asking. We're asking, do these two objects live in the same place in memory? In this case, they don't. We know how we created it, right? These are physically different memory addresses. But if I say, is list of club 0 equal to list of club 0, the answer is yes, but it's not yes because they both have putter 20 in them. It's yes because they are the same object. And how do we know they're the same object? Because they live at the same place in memory. Not because we've looked at the insides of the object. We just know we'll find it in the same place. All right, make some sense? Okay, So that's kind of the stuff from our lab, is when we create an object, you know, we created things like persons or players or something like that. If we create an object, we're creating a blueprint for holding things. We created dice object, right? That had a number of sides, and then the dice object knew how to roll itself. Here's our dice object. It had a number of sides. When we told it to roll itself, what did we do? We generated a random number between 1 and the number of sides. So this is a blueprint that allows us to build a dice object. Make sense? And we can build as many dice objects as we want. You know, if you're playing is Yahtzee, you just use 2d6. Is that right? Whatever. I think that's a common game. So, you know, a lot of games you need 2 6-sided dice, 2 independent 6-sided dice. Now you could just roll it twice, right? Okay, but usually you say, well, that's more convenient. I roll 2 because sometimes, you know, if they get the same roll, you know, something good happens or something bad happens. I don't know, it depends on the game, I guess. But you might want 2 physically separate, but identical in function dies. I have a D6, I have another D6. They would live in different places in memory, but when I roll them, they both will give me the same kind of value, a value between 1 and 6. Does that make sense? Okay, so this is just like real life. If we want to go and buy a collection of dice, sometimes D6 come in like a 6-pack. You get 6-sided dice, or if you're a Dungeons and Dragons player, you go get a dice set, you usually get, you know, a D20, a D12, a D10, a D8, a D6, and a D4. D4s also serve as the most dangerous non-lethal weapon in the world. Have any of you ever stepped on a D4 barefoot? It's the worst thing ever. Oh, worse than a Lego. Hold on. This is important on the final exam material. That is a D4. That is solid plastic or resin, or probably resin. If you step on that, there's no give. It's terrible. So then you imagine an intense game of Dungeons and Dragons back in the 80s. It's 4 in the morning, you've been playing for 24 straight hours. Things are getting intense. Somebody rolls off the board onto the floor. To make it worse, the floor was like, it was a basement, so it was like a cement floor. You had no give underneath. Now you go to find out what the roll was, but you don't have all your wits about you because you're exhausted. It crushes your soul. I screamed for a week, I think. It felt like that. Right in between. Oh, it was terrible. No. It wasn't a damaging, nothing was broken, but it felt like it should have been. You know, because you got like fat and stuff on the bottom of your feet. You're mostly protected, but I was awake after that. I tell you what. All right. So in any case, there's our kind of examples. That's where we're going with these object type things. All right, make some sense? All right, because I really want to put that in context, because in the same vein, you know, I gave the 250 exam this last week where they're doing a lot of stuff with objects, and it's something they still struggle with. Okay, so you have to start off with this mentality of, what does an object represent? Why am I using objects? Remembering that programming languages are tools for us to tell a computer what to do. And they're meant to give us all sorts of little advantages to let human beings solve problems in the way we're already used to solving problems. And with all of that in mind, it makes perfect sense for you if I say, you know, you're house shopping and you're at the place, and you're looking at the different blueprints for these houses, and you pick one and say, oh, build me this house at that address. That makes sense to us as a human. The second you get a computer involved, Even though the addresses, remember, our computer memory, all the houses are on one big long street. The second we get a computer involved, we get intimidated, right? That's all we're doing here. This is a blueprint for something far less complex than a house. You know, a house has zillions of little, cuts and uses all the different size nails and screws and has wiring and all sorts of things, right? There's land sloping. They're complex, these houses. This is simple. This keeps track of one thing. How many sides does the dice have? Okay, so this is something that allows us to represent the simple objects that exist in life that we use. This guy right here is an object. It's a phone, among other things. It's a computer, right? So this object contains a whole bunch of functionality that I can use to do different things. But when I want to use that, when I want to check my email, I want to send a message, whatever it is, I pick up this object and then I interact with this object through its public interfaces, through its role method, or through its pretty role method, whatever it is. Those are the things that are available to me for working with this object. Make sense? Okay, so let's look at, I was mentioning earlier, this idea of code wars, and I went on there and I grabbed a problem from this morning that I found was, so this doesn't really get into objects necessarily, but we're going to go ahead and build this guy into an object. All right, so the idea here is like, if any of you have ever swiped a credit card and you get a bill or something like that, a lot of times it'll just show the last 4 digits of your credit card number on there instead of showing everybody your entire credit card number, something like that. Or sometimes it's the last 4 digits of your account number or whatever it is. All right, so the idea here is they want us to, so usually when you buy something, you're asked whether your credit card number, phone number, answer to most, blah, blah, blah. Since somebody could look over their shoulder, you might want to mask it. So we're gonna write something that takes only shows the last 4 digits. Everything before that becomes masked, becomes a pound sign. All right, so this big long string is the same number of characters that existed before, followed by a 5, 6, 1, 6. Make sense? Realistically, if you wanted to be more secure, you would just have this number of pound signs not correspond with how many things actually are in the number, because now you at least know how long this number is for making guesses, right? But in any case, so we're going to write a function that takes in a string representation of something, and what it's going to do is it's going to return another string of the identical length with everything but the last 4 characters replaced with pound signs. Make sense what we're doing here? All right, so we'll just write this here. We're going to actually create a class for doing this. So we're going to create a class called masker, and we're going to define a constructor for masker, and this guy will take in a string value that we intend to mask. All right, and we'll go ahead and initialize this instance of masker's string value to whatever string was passed in. Now, just as our example here, I'm going to go ahead and I'm going to create a instance of masker. So I'm going to say val is equal to, well, here, let's call this a masked val object is equal to, I'm going to call masker, and this guy's constructor expects me to pass it a string. So I'll pass it 1, 2, 3, 4, 5, 6, 7. All right, make sense? That's what I'm going to pass that guy. Now, I expect then to be able to call a masked, so I'll go ahead and print this. Print a masked object dot mask. And what I want this to give me is something that looks like this. That. The masked version of the contents of this object. That is, show me the last four, but don't show me the things that came before that. Mask them. Make sense? So I'm going to write a function called mask that will take this particular instance's string and create a mask version of it. So that'll be def mask. All right, now how many, so we're going to talk through this. How many asterisks do I need here? Not asterisks, I'm sorry, how many pound signs? How many pound signs do we need here? In my example, I need 3, but how did we come up with 3? Well, no, let's answer at the high level first. How do I know I only needed 3 pound signs here? Good. Okay, so this whole thing has a length of 7. 7 minus 4 is 3, right? All right, so let's go ahead and remember the number of pound signs we need. Number of pound signs is equal to the length of self.string value minus 4. Make sense? Okay, so now that means that I need to, so now number of pound signs could be a negative number, right? What if I had just given it the input of 1, 2? My output should be 1, 2, because I can't even show the last 4. I can only show the last 2. Okay, so if I have a number of pound signs less than 0, I'm not going to create any. Make sense? So let's assume in this case, number of pound signs in our example is 3. I want to go ahead and I want to create a string that has 3 pound signs in it. So I want to produce that. So how do I create a string? So we'll call this guy pound sign string. It'll start off as the empty string, right? And I want to go ahead and I want to fill that string up with the correct number of pound signs. So I want to do something multiple times. I want to do repetition, right? So what for loop would I use here to make sure I create the right number of pound signs inside of this string, pound sign string? In fact, go ahead and take a couple minutes, like 3 minutes, and write the code to create a string inside of pound sign string with number of pound signs. So in this particular case, if number of pound signs was 3, this would create for me that string. So I want you to write the code necessary to create this many pound signs inside of this string. Go ahead and take a couple minutes and take a stab at that. Okay, so let's take a look at this. So we're going to write some code that's going to go and fill up # string with some number of pound signs. How many pound signs? Number of pound signs. So we're going to create a loop for I in range 0 to number of pound signs. And then we'll say # string is equal to # string concatenated with pound sign. Okay, so now if I go ahead and just print out # string, just to prove that this part's working, if I call a masked val object.mask that looked like this, I should get a # string printed out that has 3 pound signs. Go ahead and run that. There's my 3 pound signs. Okay, so far so good. We have the correct number of pound signs. Now I need to collect the last 4 or up to the last 4 items in my string, because those last 4 items are well, those last 4 items are the only parts of it that I don't want to have pound signs. I already have my correct number of pound signs, right? But now I need to create a string. Create a string with only up to the last 4 characters. In the string. That makes some sense? So I want to get the end of the string up to 4 characters. It might not be 4 characters. If I only gave it a 23 in the string, I only get 2 characters. So I want to write a loop that gets the end of string. I want to fill that guy up with up to the last 4 characters in my string. So go ahead and take a minute to write a loop that will fill up end of string with up to the last 4 characters in my string. While you're working on that, I'm going to put the homework up. Okay, so let's go solve this real quick. So we already know the first legal bucket that I want to start with. It's called number of pound signs. So in our example here, I want to get bucket 3, 4, 5, and 6 from my string. Those are the characters I want to keep. So I'm going to say for I in range number of pound signs to length of string value. I'll say end of string is equal to end of string concatenated with string value at bucket I. Then I'll go ahead and return pound sign string concatenated with end of string. String, sorry, self.string value. There's our masked value. And if I give it a smaller value, like just a 7, it should give me just a 7. Oh. Shouldn't have gotten into that string. Well, we'll look at that error next time. We'll just assume that your value has to have at least 4 things in it for it to work right now. It's just a little thing in our if statement. Okay, so there's an example there for your homework. Go to codewars.com. I'll check to see if there's like a code that I can give you to put us all like in the same group or something. And I'll put it up on Blackboard if there is. If there's not, it doesn't matter. It doesn't cost anything, so there wouldn't be any sort of like benefit. But you know, maybe there's something that puts us all into the same group. But go through there and solve some problem in Python using CodeWars. I would encourage you to find a problem that actually challenges you. So hopefully in the end, you do 4, 5, 6 problems, practice problems that give you some extra reps or something like that. But, you know, find a problem you can solve and then solve it on there. Sound good? And that is for Thursday. Questions, comments, concerns, bribes? All right, I will see everybody on Thursday.